Hello everyone! Welcome back to the AWS VPC creation playlist. So today we will explore the default existing AWS VPC, its key components, and how request flows in the AWS VPC. So we are going to understand the basic things related to the default VPC. So let's get started. So here in search bar, I will search for the VPC service. So here in the left side, you will be able to see this option, your VPCs. So here inside this, we are able to see the default VPC. So we will try to understand. So what does default VPC mean? So what is VPC? So VPC is virtualized network that lets you launch AWS resources such as EC2 instances, databases in a logically isolated section of AWS Cloud. Okay, so what does that mean? In a nutshell, we can say VPC is logically isolated network segment within the AWS Cloud, which is, I would say, specific to a region. You see, this default VPC exists in this United States and North Virginia region. Okay, so VPC gives complete control over your network configuration, including the IP address ranges, subnets, routing tables, and security settings. Don't worry, we are going to see all the things one by one, and we'll try to understand everything. Okay, so now here, if you see, for this default VPC, we can see this IPv4 CIDR block. So what does this CIDR block mean? So if you haven't seen the previous video of Networking Basics where I have explained about the CIDR block, I would highly recommend you to watch that particular video, or I will provide the link in the description. So let's try to understand here very quickly what is the CIDR block. Our VPC KDR. Let me zoom in a little bit. Okay, so for the default VPC, we can see the CIDR 172.31.0.16. What does that mean? So I have explained this already in previous video, but let's see what is the meaning of this particular CIDR, or the IP ranges or the number of IP addresses present in this CIDR block. So let's say we have formula 2 raised to 32 minus 10, which is nothing but 2 raised to 32 minus 16, which is equal to 2 raised to 16, and which is nothing but 2 raised to 16, which is 65,536, which means you can launch up to 65,536 resources within your VPC. So let's say you can launch 65,536 instances for your understanding purpose. Okay, so I hope this is clear. So VPC is region specific. We have CIDR block for every VPC. CIDR block is nothing but the number of resources which we can create in that particular VPC. Let's create one EC2 instance inside our default VPC. We're launching one EC2 instance, test instance. Let's give it a name, test instance EO1. Okay, I'll keep other options as it is for now. Okay, key pair. I don't think we have key pair. We'll create a key pair. Okay, I'll just click on the create key pair. So we'll just keep it on our desktop. Okay, so now we are not going to edit the network settings for now. Inside the security group, we have access to SSH traffic. So yeah, that's all. So we are launching the EC2 instance within default VPC. Okay, so now if we see this particular instance, private IP for this particular EC2 is 192.3.168. If you notice here, we have created one EC2 instance, and which has this private IP address 172.3.186.187. So this private IP address is from within the range of the CIDR block. If you see closely, our CIDR block base IP is 170.31.0.0, and the EC2 instance private IP is 170.31.86.187. So definitely it is within from default VPC KDR block. I hope as much is clear to you, as we have seen the networking basics in previous video. Okay? So we can say we can launch 65,536 EC2 instances in the default VPC, and we have just launched one EC2 instance. And the private IP which got assigned to this EC2 instance is within this CIDR block range. Okay? I hope that's clear and easy to understand. So this is about creating the EC2 instance. Now let's see subnets. What are the subnets? So here you are able to see 6 subnets. What are the subnets? We can say AWS VPC is divided into multiple subnets and each belonging to the specific availability zone. So what is the availability zone? We will see what is the availability zone. What is the region in the next video. So AWS provides multiple availability zones within each specific region to ensure the high availability. So what is high availability? What is EC2? What is the region? Or what are the data centers? We will see in the next video. So for now, just understand every subnet has one CIDR block, and also it has availability zone. So what does that mean? We can create subnet within any particular availability zone with CIDR block. So subnets are sections within the VPC that enables you to group resources according to their security and operational requirements. So there are two types of subnets. One is public subnet and other is private subnet. So when we will create the VPC, we will see what is public subnet, what is private subnet, or how we can route traffic using load balancer to the private subnet. So if you see, we have created this EC2 instance within this VPC, but if you see inside the networking, it has subnet associated to this particular EC2 instance. That means we have created an VPC. In that VPC, we have subnets, and inside the subnet, we have created this EC2 instance. So we did not select the subnet while creating the EC2 instance, but we will see how we can select the subnet while creating the EC2 instance or any resource. So if you see this particular subnet, it has some CIDR block and it is created in this US East 1A availability zone. Let's explore a few more things regarding the subnets. So what is subnet CIDR? So we have seen about the VPC CIDR. Now let us see the subnet CIDR. So now, if you see for this selected subnet, we have CIDR, which is 172.31.16.020. So, as I have mentioned, subnets are subgroups inside the VPC. Or we can say VPC is divided into the multiple subnets. Okay? Alright, this seems straightforward. Everything's going smoothly so far, right? So now what is this subnet CIDR? So we can say, out of this 65,536 IP addresses, we are assigning few IP addresses to this particular subnet. So that means inside the default VPC, we have one subnet. And inside that subnet, take it public subnet or private subnet. Don't worry about the public subnet, private subnet. I will explain it very simple manner. Now we have this IP range, or we can say we have number of IPs associated with this CIDR. So we have to calculate these IP addresses. So 2 raised to 32 minus 20. It will eventually become 1496. So that means within this subnet, within this particular selected subnet, we can create or we can launch 4096 EC2 to instances or AWS resources. Okay. So we have total 65,536 IP addresses. Within that, we have created one subnet which has 1496 IP addresses associated with it. So now here, if you see, we have total 6 subnets, right? So we can blindly say that for all the subnets, we have 1496 IP addresses assigned, or we can launch 4096 AWS resources in each subnet. Okay, so here we can say we have in total 4096 into 6 IP addresses. So which will become 24,576. In total, out of 65,536 IP addresses, we are using 24,576 IP addresses for 6 subnets. Okay, I hope that's clear. So now we have a total of 65,536 IP addresses in default VPC. So there are still 4960 IP addresses left in the VPC. Okay? See, we have total 65,536 IP addresses. From that, we have created 6 subnets, each having 4096 IP addresses assigned to it. So if you minus 24,576 IP addresses, so still we have 40,960 IP addresses left in the VPC. Okay? So these remaining 4960 IP addresses gives us room to create more subnets or any EC2 instance or any resource. Okay? So now one more thing I wanted to show you guys. So as we know, we can launch 4096 resources, or for understanding purpose, inside this particular subnet, be it public subnet or private subnet. Available IP for addresses are 4091. So I mentioned we can create 4096 EC2 instances. But if you see here, it is saying available IP for addresses are 4091. So where are the remaining 5 IP addresses? So 5 IP addresses are reserved for network address, default gateway, broadcasting purpose, and DNS server. What we can do is, let's visit to this subnet. Created one EC2 instance earlier. Let's see one more thing here, which is quite important. So inside Action, if you go and if you click on Edit Subnet Settings, we'll see an option here to enable the automatic assignment of public IPv4 addresses. So what does that mean? So when you're launching any instance or any resource in this particular subnet, so we are saying auto assign the public. IP address to that particular resource or that particular instance. Let's see what I'll do. I'll just uncheck it and save it. Okay, so now we'll launch one more instance in this particular subnet. Okay. We have already created the key pair. We can select that same key pair. Okay, so inside the network setting, we can edit those network settings. And here we can mention inside which VPC it should launch this EC2 instance. So for now, as we are exploring the default VPC, we will keep our subnet ID is this one, right? So we can say we want to launch our EC2 instance inside this subnet. I hope this is the same subnet. So I'll select this. By default, in this dropdown, we're seeing an option that says auto-assign public IP address is disabled. So I keep other options as it is. So we are launching the EC2 instance. Here we have the test instance 02. Now we can see this EC2 instance. You'll notice that it doesn't have a public IP. As you can see, we don't have a public IP address associated with this particular EC2 instance. So what does that mean? That means we have just created the private instance within this particular subnet. Alright, the next thing we need to look at is the route table. So what exactly is a route table? You can see root stub under this route table, and you will be able to see these two entries inside this route table. So what are those entries? What is route table? We will discuss it quickly. So route table directs traffic within the VPC. So if you see this entry, the second entry, which is named as a local, which has the CIDR block, which is nothing but our VPC CIDR block. See 172.31.0.6. So that means we can move freely within our VPC. That's the role of the route table here. So route table directs traffic within the VPC. We will see in the next video like how we can access any resource, or how we can roam inside the VPC network, or how we can connect it, or how we can access different AWS resources inside the VPC. Okay, this entry is by default. You can't remove or modify it. This is the default entry, which is included with the route table. Alright, so now public subnet. Public subnets route traffic through the internet gateway, while private subnets use the NAT gateway. So don't worry about the NAT gateway for now. We'll discuss it later. Tomorrow we're actually going to create a real-world VPC setup where we will be implementing the load balancer and the private subnets. Okay, so here 0.0.0/0, and which is named IGW, which is nothing but the internal gateway. As I mentioned, public subnets route traffic through the internet gateway. So this is our internet gateway. And what is this entry? So I hope this is also clear to you, but I'll still explain. What does this mean? How do we calculate this? 2 raised to 32 minus 0, which will eventually become 2 raised to 32, which is nothing but 4.3 billion IP addresses. So we can say inside this route table, we have this route, which is nothing but route to 4.3 billion IP addresses. This simply means directing all traffic destined for the internet to the internet gateway, and we have that entry in our route table. That means our VPC can communicate with the internet. Right. The route table determines how traffic is routed between subnets within a VPC and to the internet via an internet gateway or NAT gateway. I hope that makes sense. So, in a nutshell, we can say route table controls the route to internet for our subnets or for the resources. So, route table is responsible to control route for the internet. See, this is a whole internet route, right? And we have that entry inside the route table. We'll see how we can create the internet gateway. And what is internet gateway? But for now, just understand that route table controls the route for the internet. Okay, also route table has this local entry, which is the VPC CIDR entry, which is nothing but the VPC CIDR block where we can roam inside VPC, anywhere inside your VPC. Okay, so whenever you create the VPC, a default route table automatically gets created. So you don't need to create it, it will get created automatically. We can have multiple route tables for our VPC, or we can create those route tables, or we can have our custom route tables, or multiple custom route tables for our VPC. We'll see in which scenario we have to create the custom route tables. Okay, so this is about the root table. So we have seen the VPC, subnets, we have seen the root table. Now what we will do, we'll quickly see the internet gateway, and then we'll see like how this internet gateway affects to the root table. If we remove this internet gateway entry from the root table. So internet gateway, what is an internet gateway? An internet gateway is attached to the VPC, and this allows resources in the public subnet to communicate with internet. So in a simple way, you can say internet gateway is responsible for the internet. So each VPC can only have one internet gateway attached at a time. And it scales automatically. So at a time, we can have only one internet gateway to our VPC. And it scales automatically, so we don't need to worry about bandwidth or performance or scalability. An internet gateway only routes traffic to the instances that have public IP addresses assigned to them. This means the internet gateway will not route traffic to private instances. Okay, so quickly what we'll do, we will create one more instance. Okay, now let's create test instance. EO3. We'll select the key pair. Okay. Here, we'll select this subnet. Now you can see that it has become enabled again. By default, public IP address to our EC2 instance. Now create security group. We have a security group created already. Okay, forget about it. We'll create the new one, and which will be having SSH entry. Okay, I'll explain. What does SSH do and what is a security group? We will see this in tomorrow's video, okay? For now, just understand like how round table and internet gateway works. So I have created the EC2 instance, okay? So now we have our newly created EC2 instance here, which has this public IP address. So now what I'll do, I'll SSH to this EC2 instance, okay? Now as you can see, we will be able to SSH into this particular server or instance. If you see this private IP address, see, which is similar to our EC2 instance, see 170.31.16.123. Now what I'll do, as we have this VPC, we have the subnets, we understood the VPC subnet part. Now inside the route table, we have entry to internet gateway. Meanwhile, I'll just exit from our EC2 instance. So now, as we have claimed, the internet gateway is responsible for the internet, and our route table controls the route to the internet for our subnet or for our instance. Okay? What we'll do is we'll remove the internet gateway entry. See, I have removed internet gateway entry from this route table. So now if I try to SSH into our specific EC2 instance, it won't work because now we can say we do not have that particular route entry. Or we can say we do not have that whole internet route entry inside our route table. Or we can simply say we do not have internet access to our EC2 instance. That's what we are not able to access this EC2 instance. Okay, I hope that's clear. It won't be able to access the specific EC2 instance. So if you see here, what we'll do, we'll quickly add that entry back to the route table, okay? Don't worry about this internet gateway, I will explain. And in the next video of this series, we'll see how we can create internet gateway and how to attach it to the VPC. So now I have added that internet entry to entry back to this route table. So now if you see here, earlier the request was timed out. So now I'll try again. See, I'm able to access to my internet successfully. So the next thing we will explore is NACL. So what is a NACL, Network Access Control List? So we can say a NACL is responsible to provide us an additional layer of security for our subnet by allowing or denying the traffic based on IP address, port, or any protocol. Okay, so if you see in NACL, we have inbound rule, outbound rule. So inside the inbound rule, we can see we have some entries here. First is allow entry and second one is deny entry. So this provides us additional security layer. Or we can say this provides us additional security layer at subnet level. So NACL has numbered rules where smaller number has high priority in the evaluation process. Okay, we'll see in real time how these rule number works, or how the rule number priority works in real time. Okay, so first thing NACL has numbered list. Second thing, NACL has allow deny rules, and which works at subnet level. So now, as I mentioned, this provides us additional security layer. So what does that mean? Let's say, okay, anyway, we have launched the EC2 instance. What I will do, I just quickly install Apache server over here, and we can try to access our index page. Okay, so now we create here one index.html and add one basic demo index.html file. Okay, So we have installed the Apache server on this EC2 instance, and let's try to access our HTML page. Okay, so now if we hit our EC2 instance public address here, we will be able to see our HTML page here. I think this is not working. Let's check our security group. I'm sure we don't have the HTTP entry in our security group. Okay, I hope we are using this Launch Wizard 3 security groups. Okay, yeah. Inside the security group, we have only a SSH entry. Don't worry about the security group. We'll cover this part tomorrow, but now I'll just add the HTTP entry. Okay, so I have added the entry inside our security group. See the result. So, we have added this index hardmo. Okay, just ignore this part. I'm just adding some text. Okay, so if I reload my page, we will be able to see the updated content here. Now, as we are trying to understand what is NASL. So now in NASL, we have first entry where we are saying it should allow all the traffic. So if you see here, we have the entire internet CIDR block, which allows all inbound and outbound traffic to and from any IP address. Okay, so now as I have mentioned, NACL has numbered rules where smaller rule number has a higher priority in the evaluation process. So now what we will do, we will add one entry here. Okay, I will search my IP address. This is my IP address. I mean the public address from which I am accessing our index.html. And I will add it as a rule number 99, custom TCP. Okay, and here I will add my public IP address. Okay, we can select an HTTP as well here. Oops, yep. So this should be in CIDR format. So now I have to add this /32. So I hope this is clear to you guys. Why 32 here? Because 2 raised to 32 minus 32 is 2 raised to 0, which is nothing but 1. And 1 is nothing but my base IP address, which is my public IP address. Okay. And I will say I want to deny traffic for this particular IP address. So I will save it. So we won't be able to access our web page from my public IP address. It will either keep loading or throw in timeout error after some time. Okay, so what is happening here? So if we see our NACL, we have one rule number 99, which is saying deny the traffic from this particular IP address, which my laptop's IP address in our case. Okay, so now if you see our rules are conflicting here, let's say we are saying deny the traffic from this particular IP address and allow traffic from whole internet. So how it is working. As earlier I have mentioned that smaller rule number has highest priority in the evaluation process. So our smaller number is 99, that's all. It is denying the request for this particular IP address. So as you can see, it's still loading. It won't work, I'm sure. So now what we'll do, we'll edit the inbound rule and we'll make this 99 to 101, okay? So we'll just edit this rule number, which is greater than 100. So lower number has highest priority, and which is saying allow all the traffic. So this has the highest priority now. And now the rule number 101, which is saying deny traffic from this particular IP address. But it has the rule number 101, which is greater than 100. So as lower or the smaller rule number has highest priority. I will reload my page. Okay, see, it is working now. So this is how NACL works. So smaller is the number, highest is the priority. Okay, so this is one additional layer, additional security layer at subnet level. Okay, tomorrow we will see how security works at EC2 instance level. Okay, so what I will do, I will just remove this entry. Okay, I hope this is clear. So let's revise. Let's quickly review the things we've covered so far. So now we have seen the default VPC. We know what is the CIDR block assigned to this default VPC. Also, we can say VPC region specific. So we can create multiple or different VPCs inside different regions and can only operate and be accessed from that specific region. Okay, so now we've covered the subnet part. What are the subnets? We can say subnets are subsections inside the VPC, or we can say they are subgroups, and our VPC is divided into the multiple subnets. Also, we have covered the CIDR block for the subnet, how we can have the 26 IP addresses for the 6 subnets. Also, we have covered each subnet is allocated with 1496 IP addresses. Also, we have this AZ, where this subnet is created in US East 1B. Likewise, other subnets are also created in different AZs. Tomorrow, we'll see why we need to create the subnets in different AZs to achieve the high availability. Then we saw the root tables. So we have 2 entries in the root table. First entry is local, which is by default 1, which is allowing us to roam inside the VPC anywhere. Second entry is for the Internet Gateway, which is responsible for routing traffic to and from the Internet for resources in a VPC. Then we have seen this Internet Gateway. Internet Gateway. We'll see to move like how we can create Internet Gateway and how we can attach it to the VPC. Also, we have seen the Internet Gateway. We have to attach the Internet Gateway to VPC and it scales automatically. Correct? We'll see some more things about the Internet Gateway, but don't worry, it is very small. We have to just create the Internet Gateway and attach it to our VPC, and we have to add entry inside the root table. Okay? Then we have seen the NACLs. So what is the NACL? So we have covered what are the rules inside the NACL, how the smaller number has the highest priority. We have seen it in real time. Okay? Now let's discuss the flow of request inside the VPC. I will quickly open diagram, I guess. Yeah, this will work, I guess, for us. Okay, let me zoom in a little bit. Okay, so how the request exactly flows inside our VPC. So first of all, we can say we have request from web browser or from user. Okay, so we have a request from these users. So these are the users. We have request to our VPC. The outside block is VPC, which is default VPC. Then the request enters in the VPC through the Internet Gateway. We have Internet Gateway. We have to make that Internet Gateway entry inside the root table. So now you have basic idea about the Internet Gateway and root table. So request enters the VPC through the Internet Gateway, and Internet Gateway forwards this traffic to the appropriate root table for routing. So always we'll be having one root table when we create the VPC. We'll see you tomorrow, and we'll be having main root table. We can create the custom root table as well. But for now, when user makes any request to our VPC, this enters to the VPC through Internet Gateway. See, this is our Internet Gateway. An Internet Gateway forwards traffic to the Internet and enables communication between instances in a VPC and the outside world. So, okay, then once we have requested this root table, then route table, we'll route it to the public subnet. It reaches to this block, which is our public subnet. Okay, so this block is public subnet. So if you see inside the public subnet, here we do not have an EC2 instance inside the public subnet, but we can create, or we can have the Bastion host. This Bastion host is nothing but the EC2 instance only. We'll see it tomorrow why we have called it Bastion host and how it works, or what is the purpose, or what is the reason behind creating the Bastion host. So the request comes to this public subnet. Then at the public subnet level, or at the subnet level, we have this NACL here. So we have covered the NACL, how NACL works, or how NACL adds the additional security layer at subnet level, right? Then inside we have security group, which is other security layer at EC2 instance level. So this is how request flows inside the VPC. So now if I need to ask you guys or revise this, we can revise it very quickly now. Just let me close it. Okay, so now we have VPC. Then inside that VPC, we have subnets, we have root tables, we have Internet Gateway, we have NACL, which adds the additional security layer at subnet level. And then we have the security groups at the EC2 instance layer. So I hope this diagram is clear to everyone how our request flows inside our VPC. From user to Internet Gateway, from Internet Gateway to root table, from root table to the public subnet or private subnet, how NACL works at subnet level. Then we have the security group. At the EC2 instance level, we'll see it tomorrow how exactly works. So tomorrow you'll understand in better way like how we have to create VPC. When we create the VPC, we have to create this Internet Gateway and we have to attach it to the VPC. Then we have to create one root table, or we can make use of the main root table as well. And inside that root table, we have to make an entry of this Internet Gateway. Then we'll get to know how we can create the VPC also, subnets inside the VPC, how we have to add entries in the NACL to add an additional security at the subnet level. Then tomorrow we'll see how we can create a security group. Anyway, today we have seen how we can create the EC2 instance and how we can access that particular EC2 instance from the browser. Okay, so yeah, that's all for today's video. In the next video, we'll start creating the actual VPC work, or we will start by actually creating a real-world industry-specific VPC and understand it step by step. Don't forget to like, subscribe, and hit the bell icon so you won't miss any updates. If you have any questions or need any clarifications, feel free to drop them in the comments below. I'll help you to help. I'll see you in the next video. Thank you.